All right, let's talk about something that's at the very heart of programming, creating objects. Today, we're diving into creational design patterns. Think of these not just as code, but as master recipes for object creation that make your software way more flexible, scalable, and just easier to deal with.
So if you're a developer, you use the new keyword all day long, right? It's muscle memory. It's how we make things happen. But have you ever really stopped and asked yourself, is this always the best way? What if our go-to tool is actually painting us into a corner, making our code brittle and a real pain to change down the line?
Well, that's what this is all about. We're going to build a mental toolkit together. We're going to break down 5 really powerful patterns that go way beyond just typing new. These are alternatives that give you incredible control over how, when, and where objects get created in your code.
So what's the actual problem we're trying to solve? It really boils down to tight coupling. When you sprinkle the new keyword everywhere, you're hardwiring your code to specific, concrete classes. And you know what that leads to, right? You change one small thing over here, and suddenly everything over there breaks. It's a domino effect. That's the core issue our new toolkit is built to fix.
Okay, let's grab our first tool. We'll start with a classic problem. What do you do when you need to absolutely guarantee that a class has one and only one instance running through your entire application? Just one. No exceptions.
The best way to think about this is like a country's government, right? A country only gets one official government at a time. It doesn't matter who you ask or where you are in the country. When you say the government, everyone knows you're talking about that single, globally known entity.
And that, right there, is the singleton pattern in a nutshell. Its job is simple but crucial. First, make sure a class can only ever have one instance of itself. And second, provide one single, global way to get to that instance, just like the government.
A perfect real-world example? A database connection. You definitely don't want different parts of your program opening up their own connections left and right. That would be a mess, eating up resources and causing all sorts of potential conflicts. So what's the solution? A single shared database connection object, implemented as a singleton.
Great. So controlling the instance count is solved. But what about those objects that are just insanely complicated to build? You know, the ones with tons of optional settings and nested parts. This brings us to our next pattern. Yeah, just imagine trying to create a complex object that needs this long, painful, step-by-step setup process. If you try to shove all of that logic into a single constructor, oh boy, it gets messy, and it gets messy fast.
This is how you end up with what's called the telescoping constructor problem. It's just as ugly as it sounds. To build a house object, you suddenly have a constructor with a never-ending list of parameters. Walls, doors, windows, a pool, a garage, it's a nightmare. And since most of them are probably optional, you end up passing null, null, null for all the things you don't even want. It's awful.
But the builder pattern cleans this up so beautifully. Instead of that one monster constructor, you use a separate builder object. You just make simple, readable calls one by one. Add walls and doors. Okay, now add a pool. Then, when you're all done, you just tell the builder, all right, give me my house. So much cleaner.
And that's the builder pattern. It pulls all that complex, messy construction stuff into its own dedicated class. This lets you build your objects piece by piece. And what's really cool is you can use the same construction process to build different versions of the object. You could use one builder to make a log cabin and another to make a stone castle, all with the same simple steps.
Okay, so we can control how many instances we have, and we can build complex things step by step. But what if creating an object from scratch is just really, really expensive or complicated? What if it's just plain easier to copy one we already have?
For this, let's think about biology, mitosis, or cell division. A cell doesn't build a brand new cell from a pile of raw materials, right? No, it just splits and makes an identical copy of itself. That original cell acts as the prototype.
This is the whole idea behind the prototype pattern. You create new objects by cloning an existing one. And here's the killer feature. Your code can make a perfect copy without ever knowing the original object's specific class. All it has to know is that the object can be cloned. This is a huge deal for decoupling your code.
So when do you pull this cloning tool out of the box? First, when your code needs to be totally independent of the classes it's working with.
Second, it's a lifesaver when creating a new object from scratch is just too slow or resource-intensive. And finally, it's a great way to avoid creating a whole bunch of subclasses that are almost the same. You just configure one object perfectly and then clone it whenever you need it.
Now for our last set of tools. These tackle a different kind of problem. What happens when a class needs an object, but it really shouldn't be the one deciding which kind of object to create? It needs to delegate that decision to someone else.
This brings us to two related but distinct patterns: factory method and abstract factory. Here's the key difference. Factory method is all about creating a single object. The superclass says, I need a thing, but it lets a subclass decide exactly what kind of thing to make. Think of a logistics app. A road logistics class knows to create a truck, while C logistics knows to create a ship. The decision is delegated. Abstract factory, on the other hand, is bigger. It's about creating whole families of related objects that are all meant to work together.
The furniture shop analogy is perfect here. Think of an abstract factory as a themed furniture store. If you walk into the modern furniture factory, it guarantees that the chair, the sofa, and the coffee table it gives you will all be in the modern style. You won't end up with a crazy mix-and-match disaster. It ensures everything in the family is consistent.
And there you have it. We've just assembled an incredibly powerful toolkit for creating objects. Let's do a quick final recap of all the tools we've just collected.
Here's your cheat sheet. When you need one and only one instance, you use a singleton. Think the government. When you have a constructor with way too many parameters, you use a builder. Think building a house. When creating an exact copy is way cheaper or easier, you use the prototype. Think cell division. When you want subclasses to decide what gets created, you use the factory method. Think logistics company. And finally, when you need a whole family of objects that have to be compatible, you use an abstract factory. Think matching furniture set. So, the next time you're about to instinctively type new, just pause for a second. With these patterns, you have the power to write code that's so much more flexible, easier to maintain, and ready to scale. You've officially moved beyond just basic construction to smart, intentional creation.
So I'll leave you with this one question. Think about the code you're working on right now. Where is that monstrous constructor hiding? Is there a clear need for a singleton? A place where delegating creation could simplify everything? What part of your project could you make better right now with one of these tools? Thanks for tuning in.